So I have actually at this point migrated back to Elixir because I got a new job 3 months ago. Anyway, so about me, so I'm visiting from the US. That was a long flight and also a long time on the tarmac at Heathrow in London. The plane was broken. They got us a new one. I started using Elixir 5 years ago, and the story I'm about to tell you is from that job. But most of the time or maybe not most, but a lot of my career has been in media companies, and I'm in one again. Now one making stuff for students to move on after high school. So the story begins when I was working at Axios, which is a newspaper online newspaper in the US back in 2020. And I got put on the mobile app team, and shortly after I joined the team, we did the mobile app launch. And it immediately crashed Apollo when that first push notification with the morning headlines went out. Every morning it did that at 6 a.m. I don't do mornings. This was not going to work. So we decided to switch to Elixir. My boss had worked with it before and said, okay, that's it, we're doing Elixir. I had never touched it before. He brought in a few contractors who kind of did the initial port, and he gave me 3 weeks to learn Elixir and then take it over. And that actually worked really well, except that there was this one query. It was a single complex query that had a lot of ors in it, and it was responsible for the majority of our database load. And we kept scratching our heads over it every now and then. We would pick it up, look at it, try to figure out what is going on here, try to figure out if we could optimize it somehow. We looked at the output from Ecto and went, okay, can we write better SQL? No. So this went on for a few months until finally election season hit. And I know there's a presidential election this weekend in Poland. And I'm sure that you will all be very eagerly awaiting the results of the election. You're going to be sitting there hitting the refresh on Polish newspapers over and over, right? Because that's what happens back home. The servers get hammered on election night as everybody waits to find out the result. And all the developers stay up late trying to keep the servers alive. Where's my mouse? So I'm going to tell you a story of the time that we broke the rules and did the opposite of what your teachers tell you when you're learning to program. I was told in my database class in college that you should move as much of the logic as possible out of the code and into the database, right? Just make the database do all the work. And similarly, we were all told, normalize your data, normalize your data, normalize your data. And sometimes, actually, you need to denormalize the data to make things work right. Okay, so this is a story of when the code could be a little smarter or faster than the database. Now, I'm going to give you some context on the content management system that we built. It's fairly common that a content management system can handle multiple different types of taxonomies. You've got your categories and your tags. Maybe you have search by author. There's a bunch of different things. And the way our mobile app worked was that we had this channels page where you could subscribe to the science channel. And that would have anything that was in the science category or had a science tag, or, it was 2020. Maybe it has the coronavirus tag, right? So there were a lot of different ways that any given article or item from a newsletter could end up in a given channel in the app. And then, think about it, a user could subscribe to more than one channel, right? You might want to see science and technology, or security too, right? Well, I think we started out around 15 channels, and the number kept growing. And this query was slow. And there's so many combinations of channels you can have, right? Like, you might be subscribed to 3 different ones, and you're subscribed to three, but they're different 3, and somebody subscribed to 12 of them, and who knows? So we had to run this query multiple times for every user who visited the channels page to get it for each of their channels. And we knew from the stats in AWS that this was our toughest query. This is a simplified version, because of course, there's a date range, and there's a limit, and things like that, right? I've left off the part that's the same for everything, and just showed you what this little chart looks like when you turn it into SQL. Or sorry, when you turn it into Ecto, which is really close. When we ran this query, when we're trying to figure out what to do about it, and we ran the Postgres explain analyze to figure out what is going on, of course, that little chunk of the query came up with a cost on Postgres of 3,614. And that chunk was 8 milliseconds of execution time. And like I said, if each user is calling that more than once, and you've got, obviously, a lot of users, that's a lot of execution time added up. So I'm going to walk through how we refactored it to actually be super fast. OK, so first off, since those are parallel, what if we did 4 smaller queries? So just delete a bunch of the stuff, run it back through explain, analyze, and see what came out. Like that. There's our simplified version. OK. So that simplified version, Postgres goes, oh, that costs 16. 3,000, what was that number I said before? Yeah, 3,614, 16. OK, cool. We're on a good track here. There's also 0.125 milliseconds. Awesome. But we still had the 4 taxonomies to deal with, so multiply that time by 4. And also, we just repeated this chunk 4 times for the 4 different taxonomies. Kind of ugly. So what if we start using Elixir language features to make this a little nicer? Elixir's got atoms, and it's got that pin operator. So here is what if we make a little function to handle it. So now we're accepting what taxonomy we want as an atom into the function, and we are pinning the ID of which one we want in there. So now we have an actually reusable function. This is great. We can pass in atoms and dereference them inside the Ecto query, so we can abstract this. And at that point, what we had was 4 calls to this function in a row, which is significantly better, but we could still do a little better. Now, Elixir is known for its concurrency, right? That's why it's built on top of Erlang. We have all these fun concurrency primitives in there. So the next step we took was to run these functions concurrently. And so now what we have here is this is using the async streams. So we have an asynchronous stream of calls to the database. And we can have our list of taxonomies. Now we have one place where we list what the taxonomies are. It's only got to be stated once. If we end up adding more, spoiler, we did. It was 5 by the time I left. We just increment the list, and the rest magically goes on. So what we have here is that we're passing the list of all the taxonomies we need to search into that query. And as the results come back, we put them into a flat map to get the post out of it. So by the numbers, changing that over, we ended up reducing our CPU utilization on the database from 50% to 40%. Cool, as our standing steady state between database spikes, between push notifications that get you the traffic spikes, which is a decrease of 20%. I know you look at it, you say 50 minus 40 is 10, but it's because 40 is 80% of 50. Math is weird. I don't know, was anybody else yesterday looking at the slide with the types going, oh, they put math in my programming? So, like I said, the Postgres analyze went from over 3,000 down to 16. And the execution time that we had originally had for the query was almost 8.5 milliseconds. Having reduced it, it was 1/8 of a millisecond for each one. So if you figure, okay, there's 4 taxonomies, eventually 5, times 4, we've gone down to 1/2 a millisecond of execution time. Cool. So, like I said, this was at election time, right? And we were all worried about what was going to happen. This was not the first newspaper I ever worked for. It was the 3rd news organization I had worked for, and the 4th time I had worked for one. And so I remember the stress at like midterm elections, and the presidential ones even bigger. So I ran some benchmarks the weekend before the election, like Saturday night. I don't know why. The US does elections on Tuesdays. That's a work day. Poland's got the right idea. They're doing it on Sunday when you actually have the day off, right? Anyway. Saturday night, I'm sitting there doing benchmarking, load testing on our system, and found that we could handle 7 times as much traffic as we used to be able to handle. Yay, we're set for Tuesday. And so we had a nice stress-free election night in which I actually got to sleep. And I have apparently talked too fast because that clock down there says I should not be done yet. But if anybody wants to find me online, you can do it that way. Only one mic at a time?
I'm not sure. There we go. We got mic back. Thank you, Mackenzie. Mind taking some questions?
Yeah.
All right.
Plenty of time, apparently.
With task async for repo call, how do you control pool size? When it's over the pool size, what happens in your scenario?
Ooh. That is a good question, and I'm not actually sure because we didn't run into that.
Okay. Let me see here. Do you have any general advice for when to rely on databases versus rely on some of the code language that you're working in?
Sure. So The reason that we decided to try this approach instead was because we had already exhausted our ideas on exactly how to optimize the query itself. Now, one thing I didn't mention was that one idea that had come up that I proposed and got shot down was, what if we just say which channel you want the article to show up in the app? Like, when you're in the CMS, you just have a little drop down, put it in the science channel. And the answer was that the journalists do not want to have to make even more choices while they are putting in the articles. We cannot have another UI element. Which, that would have sort of been in the denormalize category of things, sort of. So in this case, starting at the Postgres explain analyze point is when that's what pointed us at trying to do it in the code instead. Because we started experimenting with the query. And so, obviously it's going to depend on different factors and whether you have different trade-offs, like the not being able to add the other UI element. But yeah, I would say it's based on, you got to look at what's actually happening in the database to figure out, is there a way around?
All right, next question. What was more difficult, Erlang to Elixir or Elixir to Erlang?
I would say Elixir to Erlang. For me, going from being a Python and JavaScript person over to being an Elixir person was just like, oh, this makes sense. My brain works with this. Why have I been doing all this object-oriented stuff all this time? But then I got really used to the pipe operator. I love the pipe operator. There's no pipe operator in Erlang. Also, the capitalization is distinctly different in Erlang than any other language I've worked with. So yeah, that was the thing that I was tripping over for a bit.
All right, one last question. Did you get duplicate items from the 4/5 aggregators?
I'm not sure, but running a enum unique is pretty simple at the end because we would limit it, and then because we had a limit of I think 10 per taxonomy, and then after combining them, see what comes out.
We had another question just come in.
Okay.
You mentioned that your queries have ordering. How did you handle data ordering?
Well, they were sorted by most recently published. Is that what they mean? Whoever typed that, is that what you mean?